Well, to do this, if you want to get feedback from the life cycle, you're going to need metrics. And the question is, which metrics should you use? The classic approach for automotive metrics is key performance indicators, KPIs, and that's what you typically see. You see things like deviation from the intended vehicle path, ride smoothness, how often you get hard braking, how often you get disengagements during testing, meaning that the safety driver has to override the automation, the coverage of a defined scenario catalog, here are all the possible geometries of vehicles, and did we think of all of them and test them, and risk metrics such as time to collision. Time to collision is if I don't do anything, how long until I collide, and you want to keep that number a lot higher than 0 because that means you're not getting any near misses. Now, taken individually, each one of these KPIs can help you in the design process, but some of them are more closely related to safety than others, and the question is, how do you know which ones are predictive of safety? For example, hard braking incidents seems to be correlated with good and bad drivers in human drivers, but it's hard to know what the causal relationship is, and it's easy to see exceptions or the ability to game that metric with an automated vehicle. So it's not clear that that's going to predict safety of automated vehicles very well at all. So how do you predict operational safety? Are KPIs good leading metrics for loss events? Some, but which ones? Hard to say. Does a particular KPI set cover all aspects of safety? Almost certainly not, unless you have a methodical way to evaluate coverage. And right now, KPIs are more, this is what we thought of, as opposed to here's a methodical way to get coverage of safety. So the question is, how can we select KPIs for traceability to safety to make sure the KPIs actually predict safety and to make sure we haven't left something out of what we're measuring?